Hello students, next continuing with properties of real number. In this video I shall do next theorem, theorem 10. If a and b are real numbers, then absolute value of a plus b, that is mod of a plus b, is less than or equal to mod a plus mod b. That is, absolute value of a plus b can never be greater than the sum of the absolute values of a and b. Further, equality holds if and only if a into b is greater than or equal to 0. That is, here will be equality if a into b is greater than or equal to 0. And conversely, if a into b is greater than or equal to 0, then equality holds. To prove, in the last video I have done theorem 9. So by part 4th of that theorem, minus of mod a is less than or equal to a, less than or equal to mod a. So replace a by b. To minus of mod b is less than or equal to b is less than or equal to mod b. Adding these two inequalities, we get minus into mod of a plus mod of b is less than or equal to a plus b. This is further less than or equal to mod of a plus mod of b. Now, by the part 3rd of theorem 9, in that theorem, minus c less than or equal to a less than or equal to c, if and only if mod is less than or equal to c. So if we take c equal to mod a plus mod b, and a as mod a plus b, a as a plus b, that is minus c less than or equal to a less than or equal to c. This results hold if and only if mod of a is less than or equal to c. So if and only if mod of a plus b less than or equal to mod of a plus mod of b. Now further, let us suppose equality holds. I think I shall do both parts simultaneously. Let us say a plus b mod is equals to a plus b, a mod plus b mod, if and only if is equals to scaling both sides. By second part of theorem 9, mod of a square is same as a square because a square is always greater than or equal to 0. So I may remove modulus from here. So expanding it, so if and only if again mod of a square is same as a square, mod of b square is same as b square. This mod a mod b is always mod a. So after cancelling a square b square from both sides, so if and only if a into b is equals to mod of ab. So by definition of absolute value, mod of a is a if and only if a is greater than or equal to 0. So if and only if ab is greater than or equal to 0. So this proves the theorem 10. Next, corollary. If a and b are real numbers, then mod of mod a minus mod b is less than or equal to mod of a minus b. That is, difference of absolute values of a and b, absolute value of difference of absolute values of a and b is always less than or equal to absolute value of difference of a and b. Proof. So this mod of a can be written as I subtract b and then add b. Again by the theorem 10th. Theorem 10th is always also known as triangular inequality. The previous theorem I have done, theorem 10 is always is also known as triangular inequality. So by triangular inequality, this is less than or equal to by theorem 10. That is triangular inequality. Now subtracting minus, that is subtracting mod b from both sides. So this is less than or equal to, let us call it as inequality 1. Similarly, on interchanging a and b, we shall get mod of b minus mod of a is less than or equal to b minus a, replacing a by b and b by a. And this further can be written as minus 1 into, so mod of a into b is mod a into mod b. So minus 1, the modulus of minus 1 is 1. So this is equal to, so means call it inequality 2. So both 1 and 2 are less than or equal to mod of a minus b. So oh no, we may not call it inequality 2. Take minus common. Now call it as inequality 2. So by 1 and 2, by 1 and 2, is less than or equal to, so means both signs of mod a minus mod b are less than or equal to a minus b in mod. So by definition of absolute value, replacing plus minus by modulus sign. So this proves the corollary first. Next, corollary 2. If a1, a2, an are real numbers, then mod of a1 plus a2 and so on plus an is less than or equal to mod of a1, mod of a2 and so on mod of an, called triangular inequality. This is also triangular inequality. Actually, this corollary is just an extension of theorem 10. So we shall prove it by induction on n. We do by principle of mathematical induction on n. So for n equal to 1, for n equal to 1, mod a1 is true. So the result is true for n equal to 1. Let it be true for n equal to k. Let us see. We have to show that mod of a1 plus a2 and so on plus an is less than or equal to mod of a1 plus mod of a2 and so on plus mod of an, called triangular inequality. This is an extension of theorem 10. So we do the proof by induction, principle of mathematical induction on n. For n equal to 1, even mod is less than or equal to even mod, or equality holds, so result is true. Let the result is true for n equal to k. That is call it as first. Now we have to prove the result for n equals to k plus 1. In order to prove the result, what is left hand side? ak plus 1. This can further be written as e1 plus and so on plus ak plus 1. This can further be written as plus ak. Now by theorem 10, mod of a plus b is less than or equal to mod of a plus mod of b. By theorem 10, mod of a plus b is less than or equal to mod of a plus mod of b. Now using 1, use 1, we have so by induction the result is proved. That is by induction. Therefore by induction, principle of mathematical induction, thank you.